favorite part of anatomy. My background is in biological anthropology and forensic anthropology, and I spend hours and hours looking at bones and what they can tell us. One of the main things that we would look at is a biological profile. You can determine age, sex, ancestry, stature, pathology, trauma, everything from bone. So we're going to spend quite a bit of time on this because really understanding the bones and where they're located will really give you an indication of the other organs, where they're located. A lot of times arterial supply is named after the bones that they're in close proximity to. So we're going to introduce the concept of the skeletal system. We'll talk a little bit about the tissue and bone development. Then we'll talk about the actual bones and some of the landmarks on them. So when we talk about bone, the main thing I want to get across is that and what I mean by that is that it changes throughout life. Yes, bone will stop growing in terms of length, but it will constantly be changing as you go through life, either adding bone as you move muscles, or actually losing bone in the case of certain pathologies such as osteoporosis. Now, when we talk about the entirety of the skeletal system, we're talking about more than just bone. But when you think about bone, typically you're thinking about osseous tissue. And that is the hard stuff. Okay? So the bone actually will harden through organic materials as well as minerals. And when we think of the dry bone that you typically think of when you think of a skeleton, you're thinking of the osseous composed of. Importantly also, part of the skeletal system is articular cartilage. And you'll find articular cartilage wherever you have a joint. And when I talk about joints, that's where two bones meet up together. So very important in terms of shock absorption and allowing for ease of movement of these joints. Additionally, you're going to have dense connective tissue. So you'll see me abbreviating CT quite a bit. That just means connective tissue. Now this dense irregular or dense regular connective tissue you'll find in certain areas, particularly in terms of the periosteum. And this is just a layer that surrounds all the bone except for in the articular cartilage region. That's really providing additional protection. It's also an important area where you're going to have cells differentiating to allow for bone growth. Also, connective tissue will connect to the bone. So when we're talking about ligaments and tendons, those are going to be a type of dense irregular connective tissue. You'll also have epithelial tissue. This is particularly important in terms of paranasal sinuses. So if you think of my sinuses are acting up, it's typically an inflammation of this epithelial tissue. And we'll talk about that a lot more when we talk about the skull. Lastly, I want to talk about adipose tissue and the neurovasculature. Anytime I use the term neurovasculature, that's going to mean artery, so nerves are important in terms of communicating with your central nervous system, so your brain and your spinal cord. Artery is what's bringing the supply to bones, so blood supply. And then veins are going to drain the blood, so returning to the heart. And in terms of adipose tissue, if you look at this frontal section of the bone, you'll have what's referred to as a marrow cavity or medullary cavity. And within that, in a living individual, you can have that yellow fat marrow. That's very important in terms of energy storage. So that's just a quick introduction. Key here is that we're talking about a dynamic structure, changes throughout life, so not static like the dry bone that we typically think of. So we're going to continue this discussion in terms of the functions, not only of the bone, but of the entirety of the skeleton. Our discussion of the skeletal system. And anytime I start a new organ system, I like to talk about functions, because it really gives you an understanding of why we're learning this organ system, and then it'll follow along as we actually develop more of the details. So when we think about the skeletal system, a lot of times we think about it as a support system. It keeps us upright, particularly when we're talking about safety. It allows for us to stand bipedally and on two legs. So it is that. That's one of the main functions. It's a structural framework, but importantly, one thing I want to talk about, and we'll talk about this in great more detail when we're talking about the individual bones, is in terms of as an attachment point. So you're going to have these ligaments and these tendons actually attaching to certain parts of the bone. So muscle tendons, particularly when you have these big bumps associated with bone, these are going to be attachment points. So when you have the muscle attached there, it'll contract and allow for movement to occur. Additionally, it's going to protect certain other internal organs. So the two main ones that you think of your skull, that calvaria or skull cap protecting the brain. Think of your rib cage or thorax protecting your lungs as well as your heart. It's also important to think about areas where you don't have as much bone protection. So if you think of your abdomen, you don't have any bones right here in the anterior part of your abdomen. So you have to have other structures that are serving to protect those areas. So really important in terms of the muscles as well as the tendons in those areas protected. All right, hugely important in terms of the skeletal system, assistance in movement. So if you think about those attachment points and where they're actually attaching onto the bone, if that muscle contracts, that's going to move the bone. So the muscle contracts, pull on the bone, allowing for movement to occur. Now, this is more important when you think about how the bone's actually structured. You're going to have certain areas that are completely hollow in bone, that's filled in with fat, etc. You'll have other parts of the bone that are not quite as heavy. This is allowing for that ease of movement. So very important in terms of that. So the three that I just mentioned in terms of the functions are what we all typically think of when we think of the skeletal system. But there's other functions that are just as important, and particularly in terms of keeping homeostasis within the body. And so one of the main ones is mineral storage and release. And we all heard drink your milk, get that calcium into your bones, because bone is going to store 99% of the calcium in your body. But calcium is important in other areas of the body as well. So you'll have calcium sometimes released into the blood in order to allow for your gastrointestinal tract to function properly. And so calcium can be released from bone to allow for homeostasis to keep up. So we'll talk about different ways and different glands, so in terms of your thyroid gland and your parathyroid glands, that will help keep the certain amounts of calcium within the bone, or release it if need be. Phosphorus is another mineral that's stored within the bone, not quite as high amounts as calcium, but it will play a role in terms of mineral release and storage as well. Now, bone is also important in terms of hematopoiesis, and you'll talk about this a lot more with Dr. Fox when you talk about his blood lecture. But actually, within the bone, within the red bone marrow, you're going to have blood cell production. So all types of blood cell production, red blood cells, white blood cells, etc. And that's going to be formed within red bone marrow. So juvenile bones, so when I say the term juvenile, I mean a subadult or a young individual. Juvenile bones are going to have huge amounts of red bone marrow. As you move into adulthood, there's only going to be certain areas of bone that are actually going to form red blood cells. So if we talk about epiphyses, they're going to be the ends of long bones. And then in certain other bones, such as your os coxa or hip bones, certain areas in terms of the ribs, in adulthood will still form these red blood cells. As you move into adulthood, a lot of that red bone marrow is differentiated into yellow bone marrow. And yellow bone marrow is what we think about when we think bone marrow. It's that fatty tissue that's actually within that hollow portions of the bone. And so that's going to make up the majority of the bone marrow found in adults. It's important in terms of triglyceride storage, so that fatty storage of as an energy storage for these yellow bone marrow. Down into the molecular level of the skeletal system. So what's actually making the bone? How does it get hard? And really what we need to focus on is this extracellular matrix. So this is what's surrounding those widely separated cells. And we'll talk about the cells more in the next section. But if you've ever seen a histological slide of bone tissue, you'll have this very distinct kind of darker area right here. Ever expanding rings, so very like very similar to what you see in terms of tree rings. And what's actually making up all of this? Let's talk about that in a bit more detail. And you can see some stats right here on the slide. So about 15% of water, like most things. But what I want us to focus on really are these collagen fibers and these mineral salts. So collagen fibers, this is going to be the organic material of the extracellular matrix. And this is going to be secreted by certain cells referred to as osteoblasts. Anytime you see this term blast, you know that something is being secreted. In this case, we're talking about the organic material. And then about 55% of the extracellular matrix is going to be composed of inorganic materials, or those minerals. Specifically, I always misspell this, so I'm going to make sure I do it right. Hydroxyapatite. So this is what's going to harden with the presence of these collagen fibers. So it's important to note that you're not going to have the hardness of the bone without the presence of the organic material, so those secretions of the osteoblasts. Now, when you think about it, why would you have collagen? Why would you have this component that supposedly is going to make the bone kind of softer? Because with that minerals, that's what's really making it structurally sound, very strong. But just as important, you need these collagen fibers in order to prevent against tensile pressures, okay? So important in terms of not allowing the bone to crack. You need a little bit of flexibility in the bone in order to deal with the shocks that can come from movement. And that's what the collagen fibers are really doing. So really resistance of being torn apart. And you can actually do experiments with bones. If you put a bone in a vat, say of acid, then get rid of all the mineral, you can see how flexible the bone can be. You can actually move the bone around because all that's left in there is going to be those organic materials or the collagen fibers. Whereas if you didn't have collagen fibers, you would have this really brittle bone. So equally fragile. So you need both components to really get the structurally sound and capable of movement bone or skeleton.